Namaste, Vanakkam, welcome back to Midha Guru. So today I have a very important topic as far as the ICSE 10th boards are concerned. But this video is not limited only for ICSE students. CBSE students may watch as well, as the topic is pretty much the same. As you can see behind me, the topic that we are going to study today is quadratic equations. So we'll be looking into what a quadratic equation actually is. First we will see how a quadratic equation is formed, what its basics are. We will also see its standard form, what a quadratic equation looks like. Apart from that, we'll be seeing the roots of quadratic equations, their solutions as such, the methods that we can employ to calculate these roots, and what the nature of these roots will be. Apart from that, we'll see a few example problems dealing with the different types of methods of solving quadratic equations to find these roots. So without any further ado, let's begin the lesson. Before we actually get into the chapter, let's try and understand what a quadratic equation actually is. If you may remember from our algebraic expressions, the studies of algebraic expressions, we learned about something that is known as a polynomial. A polynomial is an expression in which we use many terms together. And as such, the word quadratic came from the fact that the highest power of the variable was 2. Let us see an example of a quadratic polynomial. So quadratic polynomial looks something of the form ax square plus bx plus c. Not necessarily it can be only ax square or ax square plus bx, but generally it was of this form. For example, we had 3x square plus 4x minus 7, or we had 2x square minus 16x plus 19. Such were quadratic polynomials. We call them polynomials because they are functions of the variable they concern, right? And we don't have an actual value for this expression until and unless we substitute something for x. However, the chapter that we are covering deals with quadratic equations. What is the difference between a polynomial and an equation? The difference is that when I equate this expression to be some value, let us say that 2x square minus 16x plus 19, in this case let us say it's 0. So now we have an equal to. In this particular statement, we have written that it is equal to something. That is what we know as an equation. For example, if I just told you 2x, this doesn't mean anything. It just means 2 is multiplied to the variable x. But when I say 2x is equal to 4, it means that 2x or x particularly has a particular value that we can find out. Okay, we can do that x is equal to 2 by dividing 2 on both sides. Similarly, so this is an equation. And given that the highest power of the variable here is 2, this can be known as a quadratic equation. So just to remember, a quadratic equation is an equation on one variable in which the highest power of the variable will always be 2. Not higher than that, not lower than that. If it is lower, for example, it was of this form, we know this is known as a linear equation. If I have 3x cubed plus 2x squared plus 9x minus 17 is equal to 0, we see here that the highest power of the variable is 3. So this becomes a cubic equation. So we'll be concentrating only on the equations which have the highest power of the variable as 2. That will be our topic today. So what exactly is a quadratic equation? How is it formed? So again, going back to polynomials, if you remember, we knew that monomials, linear monomials, look something like this, right? So when we multiply two linear monomials, monomial, I mean linear binomials in which there are two terms, one being the variable and another being a constant, where a is any real number, okay? So this was the form of linear binomials. Now I tell you that if we multiply two linear binomials together, we get what we call a polynomial, that is a quadratic polynomial. Let us say I multiply x plus a into x plus b. I'll get x squared plus bx plus ax plus ab, which can be written as x square plus a plus b times x plus a times b. So now you see this is a polynomial in which the highest power of the variable is 2. So this becomes a quadratic polynomial. Similarly, if I say that x plus a into x plus b is equal to 0, I can say that x square plus a plus b x just similarly plus a times b is equal to 0, which forms the basis of what we are going to study, that it is an equation as it is equal to some value and the highest power of the variable is 2. So this is a quadratic equation. There are few things to bear in mind before we begin the chapter actually. One is the zero product rule that you must remember. So when I say that x plus a and x plus b is equal to 0, from this I can deduce that either x plus a is equal to 0 or x plus b will be equal to 0. Either of the two can be 0, because I'll only get 0 from a product of two numbers if one of them is 0. Remembering this zero product rule is very important because this will help us find solutions in one of the methods that we are going to discuss today. Apart from that, now we will move on to what actually a quadratic equation is, how it looks and what its standard form is. So now we'll try and understand what the standard form of expressing a quadratic equation is. It looks very much like this equation on the board. It says ax squared plus bx plus c is equal to 0, where a, b and c are all real numbers, right? So a is the coefficient of the second degree term or the coefficient of the squared term. B is the coefficient of this linear term, that is where the power of x is 1, it's just x, so it is the coefficient of the linear term. And C is the constant of this equation. So this is how the quadratic equation in a standard form would look like. So basically this would mean that any equation of this form, let us say 2x squared plus 3x minus 7 is equal to 0. Here you may be confused that it says plus c, but we can make a small adjustment to the equation, just saying that the sign is plus itself. It's the constant itself that is a negative 7. So this also qualifies as a quadratic equation. So any equation that does not actually look like this, but if it can be equated to form this form, it can be called a quadratic equation. Now look at the equation on the board. It says 2x squared minus 16 is equal to 0. You can say that we have a squared term and we have a constant term, but the linear term, that is bx, is missing. So does this qualify as a quadratic equation? If your answer is no, just look at what I do ahead. So now we have the same equation written in the form of the standard form. So what I'm trying to say is, every time you see an equation that misses one of the terms, but here important to remember that the x squared, that is the variable squared term, shouldn't be missing. Because if I hide this part, this clearly becomes just a linear equation because the variable is only x, that is a linear term. So this becomes a linear equation. It means apart from the x squared term, if any of the two terms are missing, we can still call it a quadratic equation, because here we can say that the linear term's coefficient is 0. It's not the linear term that is missing, it's just that the coefficient of the linear term is 0. So this is the standard form of a quadratic equation. And again, it is not necessary that an equation looks similar to this, but if we can equate it in such a way or adjust it in such a way that it comes to this form, we can say that that particular equation is a quadratic equation. Idea or concept that we are going to see is that of the roots or solutions of quadratic equations. What are these roots or solutions? Going back to the easier chapter, that was the linear equation, let us say I have an equation that says 2x is equal to 8. Now we know how we could find a solution for this. We equate it because there's only one x. What we do is we just isolate the variable itself on one hand of the equation. So this becomes, I take 2 to the other side, it becomes 8 by 2, which is equal to 4. Here I would say that 4 is a solution for given equation, right? Let us talk about a linear equation in two variables. We had x plus y is equal to 8. If I said x was 2, you would say that 2 plus y is equal to 8. So y is equal to 8 minus 2, which would be 6. So I would say that 2 comma 6 is a solution for the given equation. Such were the roots or solutions. So a solution in essence can be said, it's a value, such a value that would satisfy our given equation. And it's not very different for quadratic equations. There's just a slight difference. As you remember, in linear equations in one variable, there would only be one solution. And as we are dealing with quadratic equation in in one variable, in only a single variable, how many roots can a quadratic equation have? Well, if the power of the variable is 1, obviously there would only be one solution that would satisfy said given equation. But when we move to a quadratic, that is with the power 2, always remember that that equation is going to have two solutions. That is, both those solutions can satisfy the given equation by themselves. They don't need to be taken together, but even by themselves, each of which will satisfy our given quadratic equation. Let us see an example. I have x square minus 6x plus 8 is equal to 0. So I need to find roots such that, let us say, m and n are roots of this equation, right? Now I say that m and n are roots. So what are the conditions? It is if and only if I substitute m in the place of x everywhere, that is m square minus 6m plus 8 is equal to 0. If this is true and n square, that is I substituted n in its place, 6n plus 8 is equal to 0, are both true. Only when both these conditions are satisfied can I say that m and n both are roots of this given quadratic equation. Coming back to the equation itself, it was x square minus 6x plus 8 is equal to 0. Let us try and substitute a value to see. Let us put 2. Let us say x is equal to 2. So we get 2 square, which will be 4, minus 6 into 2, which will be 12, plus 8 is equal to 0. I add 4 and 8 and I get minus 12, which will be equal to 0. So here I can say that 2 is a root of the given equation, right? Let us say now that x is equal to 4. Now I have that 4 squared, which will be 16, minus 6 times of 4, which will be 24, plus 8 is equal to 0. I add 16 and 8, I get 24 minus 24, which is equal to 0. So 0 is equal to 0, and again I can say that 4 is a root of the given equation. So hence I will write that x is equal to 4, 8. So either of these can, as we saw that when, sorry, I wrote 4, 8, that's my bad. So when I substitute 2, I also get that the equation is true. It stands true, 0 is equal to 0. Similarly, when I put the value of x as 4, I also get that the equation is equal, that is, it is satisfied. So here I can say that 2 and 4 both are roots or solutions for said given equation. So that is the idea of roots, and that is how we see whether a given number. So the question form here can be, I'll ask you whether 2 and 4, I'll give you an equation, so any given equation, and I'll give you two arbitrary numbers, and I'll tell you find out whether these are solutions for our given equation. So let us see a few examples dealing with this concept. So on the board we have the example question. It says, is x is equal to 5 a solution for the equation x square minus 2x minus 15 is equal to 0? So how do we check this? As you may remember, we write the equation down. It says x square minus 2x minus 15 is equal to 0. This is our equation. I say x is equal to 5, taking x is equal to 5, which was given to us in the question. So what am I supposed to do now? So now I substitute the value 5 wherever I see x in this question. I say 5 squared minus 2 into 5 minus 15 is equal to 0. Let us see. So 5 squared would be 25. 2 times 5 will be 10 and minus 15. So we have the 25 minus 25. Is it equal to 0? We see that yes, it is equal to 0. So we get 0 on the left hand side and we have 0 on the right hand side. So we can say that 5 is a solution. And please don't be confused with the word solution and root. They mean one and the same thing in this particular context. So 5 is a solution or root for the given equation. So anytime you come across such a problem that says it gives a certain arbitrary value, then find out if this is a solution for a given equation. All you are supposed to do is substitute that value in place of wherever you see the variable in that equation, and if the equation still justifies out to be equal or satisfied in this case, then we can say that given arbitrary value is a solution for our said equation. Let us see one more example before moving on. Now the next question says, if 2 by 3, root 2 by 3 is a solution for this equation, find the value of m. Before this, we were asked whether the given value was in fact a root or solution for the equation. However, this is turned upside down. It says that this is a solution. So it's not asking us to find out, it's telling us that this is a solution for the given equation. So based on that, we are supposed to find out the value of m. How do I go about this? So the method is quite almost the same. You have to understand that if this is given as a root, again the condition is same. It will be a root if and only if it satisfies this equation. Now here it says that it already is a solution, so we will take it for granted that it will satisfy this equation. So we write the equation down, 3x square plus mx plus 2 is equal to 0. And we take x is equal to root 2 by 3. Then I go about substituting the values. So I get 3 into root 2 by 3 whole square plus m into root 2 by 3 plus 2 should be equal to 0. So when I open this bracket, I square it up, I get 2 by 3 plus so now this 3 and 3 gets cancelled out and I get m into root 2 by 3 plus 4 is equal to 0. So then I'll say that m into root 2 by 3 is equal to minus 4. And then m is equal to minus 4 into root 3 by root 2. Now we know that 4 can be written as 2 into 2 or 2 can be written as 2 into root 2. Root 2 into root 2, sorry. So I'll say minus 2 into root 2 into root 2 into root 3 by root 2. So don't be confused as to what this is. If I can write minus 4 as 2 into 2, I separated 1 2 as root 2 into root 2. And now we'll cancel this out. So we get that m is equal to minus 2 root 6. So see, we covered two concepts based on roots and solution. In the first question, we saw that we had an equation and we are supposed to find out if the given value was a solution or not. In that, we just substituted the values to see whether the equation was satisfied. And as it was, we said that it was a root. In that case, if it wasn't satisfied, that is, the equation wasn't satisfied after substituting the given value, we would have said that it is not a root. And the second type of problem that we just saw is that they give us an arbitrary value and state to us that it is in fact a solution. And there will be some other variable in this question that we are supposed to find. So we go about the business in the same way, almost. That in the earlier case, we were looking out for, checking out whether the equation would be satisfied or not. However, in this case, as it is given it is a solution, I take it for granted that it will satisfy the equation, and based on that, I will find my variable. Okay, let's move on. I hope by now you all have got the concept of what a quadratic equation is. It is in fact an equation in which the highest power of the variable is twice or 2. You have been hearing this over and over again, you may be bored with it. So what about it? Now that we learned what root solutions are, actually what they mean, what a root is, it satisfies the given equation, right? So when I'm given an equation, I'm not always given a root, right? Just as in the case of linear equations. So how do I find out what these roots are? I cannot just pop up a random variable or a value in my head and say that that will be the value. And it cannot always be true, right? Sometimes it may take a lot of guesswork, it may take 100 tries and you still may not come up with an answer. Because quadratic equation can be formed by rational numbers as well. So while you are checking out different integers or maybe decimal numbers, the rational number slipped your head and you did not attempt it. So you may not find it. So how do I find out the solution of any given quadratic equation? Well, there are two methods that we can use to find out the solutions of given quadratic equations. The first is the method of factorization. As you may know, factorization is dividing any given value into its factors. As you may remember the earlier example that we used to understand how a quadratic equation is formed. If you see the board, I say x plus a into x plus b is equal to 0, and this formed the given equation x square plus a plus b x plus ab is equal to 0, right? So now let us say again with the zero product rule, either x plus a is equal to 0 or x plus b is equal to 0. If I use any one of these and say x plus a is equal to 0, so x is equal to minus a, and similarly x is equal to minus b, which means these two should be, maybe, we'll check it out, but these two should be solution for our given equation. We'll try it out. So when I put minus a, I get a square plus a plus b into a plus ab is equal to 0, which I get a squared, oh this will be minus, I'm so sorry, so this will become minus a square minus ab plus ab is equal to 0, which we see that when these cancel out it becomes 0 is equal to 0. So I can say that minus a is a solution, and similarly when I substitute b into the equation, I will see that it also forms this parity, that is it comes 0 is equal to 0, or I can say that the equation is satisfied. So here I can say that a and b, minus a and minus b, I'm sorry, are solutions or roots for our said given equation. So basically when the equation is of this form, that is in its standard form, if you can see a is 1, b is a plus b, and c is ab, as you can remember from ABC of the standard form. So we can factorize it back as we came from here to this equation. So this time we won't be given this values, we'll be given this equation itself. So we'll split the middle term such that we can factorize it back to the original values. I'll just show you an example. Let us just say the same equation. It was x square plus a plus b x plus ab is equal to 0. From this I'll just split the middle term into ax and bx and ab. Again, for understanding, this is the equation we have been given. We don't know that minus a and minus b are solutions yet. We are going to find them out. How? So I split the middle term into two parts. Then here I'll be taking x as common, I'll get x plus a. And here I'll take b as common and I'll again get x plus a. So now I get x plus a into x plus b is equal to 0. Then I'll say that either x plus a is equal to 0 or x plus b is equal to 0, from which I can equate that minus a or x is equal to minus b. So these are my two solutions for the given quadratic equation. The other method is not so simple, but however you would be agreeing that even the first method was not so simple as well. But as soon as we get into it, as we go more and more, practice more and more, you will see that if you get a hang of it, it becomes quite easy to solve by factorization. But sometimes it's not possible to split the middle term to factorize our given equation. Sometimes we have to use the method of the quadratic formula. The quadratic formula says that x is equal to minus b plus or minus the square root of b square minus 4ac, the whole divided by 2a. If you are confused, because we said that every quadratic equation has two solutions. So you may be seeing that here we have only written x and this big value, which means that it should somehow give us only one. But if you can see clearly here, it comes plus or minus. So one of x values will be minus b plus the root of b square minus 4ac by 2a, or x is equal to minus b minus the square root of b square minus 4ac by 2a. Now you may be confused what these a, b, c are. They are nothing but what we saw in the standard form. A is the coefficient of the square term or the degree 2 term, b is the coefficient of the linear term or the power 1 term, and c is the constant of the equation. If we look at an equation, isolate the values of a, b and c and substitute it to this formula given here, we will find out both the roots of said quadratic equation. And we use this method when factorization is impossible or the question mentions us to do so. So just remember, if your question says find the roots or solve this quadratic equation and does not specify the method, you can go ahead as well and try by factorization. But if it's not possible to factorize that, we can use the quadratic formula. Now you may be seeing this term that is inside the square root. It is the same in both the solutions, and we call this as the discriminant of the quadratic equation. So what is this discriminant and what use is it of to us? Let us try and understand how a discriminant helps us to understand the nature of the roots of the quadratic equation without actually solving the quadratic equation itself. So let's get into it. So as I said, the part of the quadratic formula that comes or falls under the square root is known as the discriminant, and it is portrayed by d, which is equal to b square minus 4ac. Just so that you can remember, I'll write the formula down once again, but instead of writing this whole part under the square root, I'll just write d, which is our discriminant, by 2. Here you need to understand very well that if I am looking just at the nature of the roots, I'm not actually solving the equation, but just trying to understand what my roots are going to be. So what help is this of to us? Well, a root can be of 3 types. One, they can be real numbers and they can be both unequal. As we saw in one example that we got roots 2 and 4. So they were both real numbers and both were not equal to each other. Another condition is that both the roots are real numbers but they are the same, that is, they are equal to each other. And the third being that the roots are imaginary. What does all this mean? How do we find out? If you look at d very well here in the quadratic formula, it falls under a square root. And square rooting of numbers is not as simple as it may seem, because we cannot find the square root of negative numbers, right? So what does all this mean to us? Well, let us look into it. If d is greater than 0. So now I calculate this value of b square minus 4ac and I see that it is greater than 0. That is, the discriminant d is greater than 0. Then I can say that the roots are real and unequal. That is, there will be real roots which can be found, which can be expressed as rational or irrational numbers, and they are not equal to each other. Now let us say I calculated this entire value and I found out that it is less than 0. Which means, again, if I write down the formula here just to remember, just to explain this very much better to you. If this is a negative number, how do we calculate the square root of a negative number? Well, there's no analytical approach to it as of right now. Maybe we may find it in the next 10 years. But as of right now, I know that I cannot find the square root of a negative number. So this number itself becomes imaginary because I cannot calculate it. So as you can understand, if I'm supposed to find the square root of a negative number, I'm not going to be able to do that, equate it here. So this entire value will become imaginary. That is, both the times when we do plus square root of my whatever the d, the negative value that d is, or minus of that negative square root of that negative value. So if d is less than 0, the roots are imaginary. So they are not real anymore, they are imaginary numbers. Something that we cannot imagine or cannot express. Now we saw that in one case d was greater than 0, that it was some positive number. So we took out the square root and we got 2 roots which are real but they are not equal. Second time we saw that d was a negative number, it was less than 0, then the roots were imaginary. However, what about when d is equal to 0? If you concentrate only on the quadratic formula, as I told you, from here we can deduce that one x will be minus b plus root d by 2a and the other x will be minus b minus root d by 2a. So here you have to understand, if d is equal to 0, that is, the value under the square root is 0 in both cases, it's going to come out as 0, that is x minus b plus 0 by 2a, and x is equal to minus b minus 0 by 2. And adding or subtracting 0 does not change any value, which means that if we forget this for a while, we will see that both the roots are just identical. They are minus b by 2a, which means that in this case, just a second, I'll erase all this from here. So if d is in fact equal to 0, we can say that the roots will be real numbers, right? But they will both be equal to each other. So without actually solving a quadratic equation, just by calculating the discriminant, we can see whether the roots are real and equal, whether they are real and unequal, or whether they are imaginary roots. What use is it of to us, you say? Then what if I am sitting solving a quadratic equation that has imaginary roots? I have no way to find out, right? Till I try solving it and I get stuck up and I think that there's something wrong with me. I'm not good at maths. But if I do this before solving a quadratic equation, I know exactly what the nature of these roots are and whether I should move ahead with solving the given equation. So now that we have understood a little bit about discriminant and how it helps us to find out the nature of roots of the given equation without actually solving the equation itself, let us see a few examples to get a better hang of it. So now that we understood how the discriminant helps us to find out the nature of roots, let's try and apply that knowledge to a few questions. The first type of question says that without solving, comment upon the nature of the roots of the following. This is the first type of question that you're going to maybe face in your exams, maybe face in your school exam, maybe in the board exam. So they'll give you an equation and they'll tell you, look, you're not supposed to solve it, but you're supposed to tell us what the nature of their roots are. So the first equation is 6x squared minus 13x plus 4. So again, just to remember, the standard form was ax squared plus bx plus c, from which I'll get that a is equal to 6, b is equal to minus 13. Not 13, but minus 13. And c is equal to 4. What's the next step? I find out the discriminant. Now if you remember, discriminant was b squared minus 4ac. So I'll just substitute these in the places. So that is minus 13 whole squared minus 4 times of 6 times 4. So minus 13 squared would be 169 and minus 4 times of 24 is 96, which would give us roughly so the discriminant comes out to be 73. And if you remember from the conditions of the nature of roots, if the discriminant is above 0, that is greater than 0, we can say that the roots of the given equation are real and unequal. Okay? Now we move on to this next equation. It says 2x squared plus 8x plus 9 is equal to 0. Think about what a, b and c will be for a while I sip some water. Any clues yet? Yeah. So a is equal to 2. Now in this case, b is equal to 8 and c is equal to 9. I'll just erase that 2 because it's not very clear. I'll write it again. So a is equal to 2. Now all I have to do is, again I have to substitute these values in the formula of the discriminant. It is b squared minus 4ac. So d is equal to b squared, that is 8 squared minus 4 times of 9 into 2. So I'll be getting 64 minus 18 times 4 is 4 plus 40 plus 32. 64 minus 72, which will give us minus 8. And we know that if the discriminant is a negative number, its square root is going to be imaginary. So the roots of the given equation will be imaginary. So this is how this particular discriminant helps us to determine the nature of roots without actually solving the equation. So as I said, this is one type of question that may be formed based off of this knowledge of the nature of roots. The other type of question may be that in this first type C, we were told to comment on the nature, that is we are supposed to find out the nature of said given roots of this given equation. The other type of question that can be formed will be in which you will be told that this particular equation has a certain kind of root and more often times than not it will be that it has equal roots. So what it's trying to say is, the question is trying to say that look, this equation has equal roots. So from that we can say, when does an equation have equal roots? That is when the discriminant is equal to 0. That is what the question is trying to give you. This is the hint that the question is trying to give you by itself. So now from here I am supposed to find the value of the second variable in this equation, that is p. I'll write the equation down a bit clearly here. X square plus p minus 3x plus p is equal to 0. Just remember that in equal roots the case is when discriminant is equal to 0. But before all that, let us say what a is. So there is no number written here. So what will a be? A won't be 0 bachas, it will be 1. Similarly, b will be equal to p minus 3 and c is equal to p. Now as we know that the condition given is that the discriminant is 0, and we know that the discriminant is nothing but b square minus 4ac, which is equal to 0. Now further we will just substitute these values here. So p minus 3 whole square minus 4 times of a into c, which will be equal to p is equal to 0. So a minus b whole square will be a square plus b square minus 2 times of ab and minus this, which will be p square plus 9 6p minus 10p is equal to 0. So here again we come at a conjuncture where this is a quadratic equation. It may seem very difficult at first that you don't know how to solve a quadratic equation, but as I do, I'll try to go about it, okay? The method that I am going to use is by factorization. So this is my term, the middle term. When I write it the equation the proper way, it will be minus 10p plus 9, because this is a standard form, right? P square, the variable squared, and the variable to the power 1, and then the constant. So now I'm supposed to divide this or break this down such that the equation may get factorized. So I write down minus 9p minus 1p plus 9 is equal to 0. As you can see, minus 9p and minus 1p will form minus 10p again. We'll understand this method in a lot more depth, please don't worry about it. This is just to solve the question. No? So anyways, I take p common here, I get p minus 9, and here I take 1 minus 1 common, I get p minus 9. So then I say p minus 1 and p minus 9 is equal to 0. So again, following the 0 product rule, either p minus 1 will be equal to 0 or p minus 9 is equal to 0. So either p minus 1 is equal to 0 or p minus 9 is equal to 0. So p is equal to 1 or p is equal to 9. So this is how we can use the knowledge of the nature of roots of given quadratic equations by using the discriminant, and these are the type of problems that you may come up with, that the questions paper may have based off of this concept. So now that we have seen this method, let us move on to the methods of actually solving quadratic equations. One being the factorization method and the other using the entire quadratic formula. So now let's look into what these methods are to find out solutions of the given quadratic equation. Now that we have understood the discriminant, so let us look at the quadratic formula first. So this is the quadratic formula. It says x is equal to minus b plus or minus root of that discriminant, the discriminant being b square minus 4ac, the whole divided by 2a, which means we will be getting two roots from here. One will be minus b plus the root of d by 2a, and the second will be minus b minus the root of d by 2a. These are the two roots that we will be getting from said quadratic formula. But what does all this mean? So let us say we have an equation (2x squared plus 4x minus 6 is equal to 0). Now from this I say that a is equal to 2, b is equal to 4, c is equal to minus 6. So now first I'll find out the discriminant, which is b squared minus 4ac. So b squared is 4 squared minus 4 to 2 into minus 6, which will become 16, and this minus and minus will become plus. Plus 12 into 4 is 48, which is equal to 64. Now I apply the quadratic formula that x is equal to minus of b plus or minus the root of d by 2a. So x will be equal to, as b is 4, we will say minus 4 plus or minus the root of d, which we got to be 64, by twice of a, which itself is 2. So we will get x is equal to minus 4 plus or minus the root of 64 being 8 divided by 4. So now x is equal to minus 4 plus 8 by 4 and minus 4 minus 8 by 4. So x will be equal to 1 or x will be equal to minus 3. So from this given equation, based on the quadratic formula, we found out that the roots of the equation are 1 or minus 3. Just so that you have no doubts that the sir teaching you something wrong, let's just check it. If these are the solutions, they should satisfy our given equation. So first time it is 2 times 1 square plus 4 times of 1 minus 6 should be equal to 0. We will get 2 plus 4 minus 6 is equal to 0. So 6 minus 6, which is also equal to 0. So this root is accounted for. And similarly, we will find it for minus 3. 4 into minus 3 minus 6 is equal to 0. We will get minus 3 squared, 9 times 2, 18. And this will become minus 12. Minus 6 is equal to 0. This 18 minus 18 is equal to 0. So hence the second root is also accounted for. So this is how we use the quadratic formula, this quadratic formula, to find out the roots of said given, any given equation. And just to say, this formula is to be used when the question mentions that you are supposed to find the roots by the quadratic formula, or when factorization seems out of hand. And we'll understand factorization in a bit. But before that, let us try and see a few examples of how this quadratic formula is used to find solutions or roots for any equation. For example, the question on the board. It says x square minus 6x is equal to 27. So first things first, the first step that we must do is to place this equation in form of the standard form. So we can say that it is x square minus 6x, and bringing 27 also to the other side, it becomes minus 27 is equal to 0. So now a is, again, if there is nothing, a is not 0, it's 1. B is equal to minus 6 and C is equal to minus 27. So first we find the discriminant, which will be b square minus 4 times of AC. So minus 6 whole squared minus 4 into 1 into minus 27. This becomes 36, and 4 into, and this minus minus becomes plus. 4 into 27 is 108. This will be equal to 144. Now we apply the quadratic formula, which is x is equal to minus b plus or minus root over d by 2a. Applying this, we get minus of b. If b is minus 6, minus of b will be 6, plus or minus the root of 144 divided by twice of a, which is 1, so 2. So from here we get x is equal to 6 plus the root of 144 will be 12, so 6 plus 12 by 2 and 6 minus 12 by 2. So x will be equal to 6 plus 12 is 18 by 2, which will be 9, or 6 minus 12, which is minus 6 by 2, which is minus 3. So this is how we apply the quadratic formula to find the roots of any given equation based off the discriminant and this whole formula. So we got the roots as 9 and minus 3. But wait a minute, the questions will always not be, that the values will not be so simple that you get a integer or a fairly simple calculation every time. Sometimes it requires a bit more of calculation. So let's just see one more example, or a few more examples if you will. So this next question says 2 by 3x is equal to minus 1 by 6x squared minus 1 by 3. Let us go about our business and see what happens. So again, if I bring it in the standard form, I bring both of this to the other side, I get 1 by 6 x squared plus 2 by 3 x plus 1 by 3 is equal to 0. If I take this whole as one fraction and take the LCM as 6, which clearly is 6, 6 and 3. So I get x squared plus, I multiply this by 2, I get 4 plus again by 2, which is equal to 0. And 6, taking 6 to the other side, I get x squared plus 4 plus 2 is equal to 0. This is my final equation, or the equation that I am supposed to solve. So I get a is equal to 1, b is equal to 4 and c is equal to 2. Now to calculate the discriminant, it is b squared minus 4 times of a times of c. So I get 16 minus 8, which is equal to 8. Now from here what I am going to do is that I am going to solve with the quadratic formula, that is x is equal to minus b plus or minus root over d by 2a. So x is equal to minus of b, which is minus 4, plus or minus the root of 8 divided by 2, as a is just 1. So now I'll get x is equal to minus 4. Now I need to calculate the root of 8. Like in the earlier cases, the root was either 8, which was a whole number, or it was 12. But here I know that 8 does not have a perfect, that is, there is no perfect square root. So for that, what we are going to do, we'll just see the table for once, and we get that root of 8 is 2.828. We'll take it up to that value. So plus or minus 2.828 divided by 2. From this I will get x is equal to minus 4 plus 2.828 by 2, and x is equal to minus 4 minus 2.828 by 2, which will give me two roots. One will be equal to so, as unlike the earlier case, we don't have a perfect square root for d. So we are supposed to see our log tables, which you have at the back of your books, and also you'll be getting one in your board exams. So we look at the the square root tables. We see the value of the square root, we replace it, and then we go about our calculation pretty much the same. And we got that the roots of said equation is minus 0.59 and minus 3.414. Let's just look at one more example to understand this method once and for all. So the next question is 5x squared plus 10x minus 3, and we are supposed to solve the quadratic formula by the quadratic formula up to 2 decimal places. So answers will be rounded off to 2 decimal places. Excuse me. So from this equation itself, I can see that a is equal to 5, b is equal to 10, and c is equal to minus 3. So now I go about calculating the discriminant. So the discriminant will be 10 squared minus 4 into 5 into minus 3, that is 4ac. So I get 100, and this minus minus becomes plus, 4 into 5, 20 into 3, 60, which is 160. Now I apply the quadratic formula. Minus of b, which will become minus 10, plus or minus the root of 160 divided by twice of a, which will also be 10. Now in this 160, I can write it as 16 into 10. And I know that 16 is a perfect square, so I'll just take out the value, which will look something like this. So plus or minus 4, as the square root of 16 is 4, and as this is 16 into 10, so 10 will be left over. Now again, I need the value of root 10, because I know 10 is not a perfect square. So again, I go back to my square root table. I see that the square root of 10 is 3.16. Minus 10 plus or minus 4 into 3.16, the whole divided by 10. So I multiply 4 into 3.6. So x will be equal to minus 10 plus 12.64 by 10, or x is equal to minus 10 minus 12.64 by 10. So x will be equal to 0.26, and as I said, it will be 0.264, but if we are supposed to square it, round it off to 2 decimal places, I write 0.26, or x is equal to 22.61, minus 2.26. Just I'll clear that out a little bit. So this root will be minus 2.26. So this is how we employ the quadratic formula method to find out the roots of any given equation. So now that we have seen it, let's move on to the next method, which is finding the roots of any given quadratic equation by factorization. So the next method of finding roots or solutions for any given quadratic equation is the method of factorization. If I go back to the standard form, it was ax squared plus bx plus c is equal to 0. And as we saw in a few examples that I was supposed to use it, even though we didn't know of it by then, but I did anyways. So I split this middle term, and for that it's very necessary that you arrange any given equation in this form itself. Then the x term, that is the linear term, the term that has the variable to the power 1, is the term that we are always supposed to split. And to split it in such ways, let us say that I say ax square plus m plus n x plus c is equal to 0. So I have to choose two values of m and n such that m plus n is equal to b and m into n is equal to a into c. These are the conditions that you must remember to apply this split the middle term method to factorize it, right? So here again, you must choose two numbers such that the sum is equal to the middle term and the product is equal to the product of these two. What does all this mean again? Let us take an equation that is x plus 1 by x is equal to 2.5. So before we go ahead, we need to calculate it out because this does not look quite like a quadratic equation yet. So when I take the LCM as x here, I get x square plus 1 is equal to 2.5, which in turn gives me x square plus 1 is equal to 2.5 x. And this whole equation I'll just multiply by 2. Then I will get 2x square plus 2 is equal to 5x. And bringing it to this side, I'll get 2x square minus 5x plus 2 is equal to 0. Now this is the equation that must be factorized to find the roots of said equation. So now I have to choose two numbers, as I said, such that their sum is equal to minus 5 and their product is equal to 2 into 2, which is 4, but a positive 4. Let us see what happens if I write down this as 4x minus 1x plus 2. Now minus 4 and minus 1 will sum up to give minus 5, and when I multiply them, they will give us a into c, which is 4. So this might be the right factorization. Let us see what happens. I take 2x as common, I get x minus 2. And here I take minus 1 as common, I also get x minus 2. Then I can say that 2x minus 1 into x minus 2 is equal to 0. So here comes when I told you that you must remember, that you must remember the zero product rule. It is for this particular method. So I come up to that 2x minus 1 into x minus 2 is equal to 0. From the zero product rule, this would mean that either 2x minus 1 is equal to 0 or x minus 2 is equal to 0. From here, we can evaluate that x is equal to 1 by 2 or x is equal to 2. So this is how we factorize by splitting the middle term, and we find roots for any given equation. So this is the method of factorization. Let us see a few example questions to apply this method so it will help us understand better. As you can see, I have an equation. It says that 6 by x is equal to 1 plus x. First things first, I'll bring all of them to one side so that I can equate the equation to 0. I'll say x minus 6 by x plus 1 is equal to 0. Again, I'll take x as the LCM and I will get x squared minus 6 plus x is equal to 0. Now I have to calculate x. So I take x to the other side. I take x to the other side. I get the equation x square minus 6x, minus 6 plus x is equal to 0. Which I'll write as x square plus x minus 6 is equal to 0. See, I did a subtle change. I brought the x to the center because that is the term I'm supposed to split. If I write down the equation like this, some student may be confused that minus 6 is supposed to be split. No, it is the x term that is supposed to be split. Now again, I have to find two such terms that add up to x, the coefficient here which is 1, and their sum product is equal to 1 into minus 6, that is minus 6. So look very carefully what I am doing here. In the previous sum, the product was supposed to be positive, but here I have to get a negative product. So just keeping that in mind, you already know that this has to be split into two terms, one a positive term, the other a negative. So that when we multiply it, we get a negative value. So I write 3x minus 2x. When you add both of them, you get x. When you multiply both of them, you get minus 6 into 1. So I write minus 6 is equal to 0. So now I have split the middle term. Apart from that, I take x as common, I get x plus 3. Here I take minus 2 as common, I get x plus 3. So then x minus 2 into x plus 3 is equal to 0. Coming back to the zero product rule, again, either x minus 2 will be equal to 0 or x plus 3 will be equal to 0, which implies that x is equal to 2 or x is equal to minus 3, both of which will be solutions or roots for our given quadratic equation. Let's just see a few more examples. So now another type of question that you may get is this. This does not look like a quadratic equation right off the top, but it does not mean that it's not a quadratic equation. Nothing is written here in between these both and in between these both. And in algebra, the default operation is multiplication. So what we are supposed to do is, first we are supposed to multiply these two and these two together to form our quadratic equation. On the left hand side, when I multiply, I get 2x squared plus 8x plus 2x plus 8. And on the right hand side, I get x squared plus 3x plus 7x plus 21. I bring all of this to one side. I add up here, it is 10x, and again I add up here, it is 10x. So I get 2x squared plus 10x plus 8 on this side, and when I bring all the terms to this side, I get x squared minus 10x minus 21 is equal to 0. Look what happens. I subtract it, get x squared, and the 10x gets cancelled in itself, and 8 minus 21 will be equal to, so x squared is equal to 13, which means x will be equal to root over 13, which will be plus or minus the root of 13. So in this example, I wanted to show you that sometimes the equation may not be what we have practiced. But here, as it was x square was equal to something, we could directly equate it, that is equal to the plus, the positive and the negative, that is the two roots. So if you don't understand, one will be the positive root of 13 and one will be the negative root of 13. Again, looking at the square root tables, we can calculate these values and write down the answer. So this is one type of question that you may come across, and you may be surprised that this does not look like our original quadratic equation, or it does not seem to follow any of the rules of what we learnt to calculate roots and solutions for given quadratic equations. So I'll just do one more example and we will try and understand this method once and for all. So now I have x square minus a plus bx plus ab. Here I'm supposed to find the root by factorization. So when I open this bracket out, I get minus ax minus bx plus ab is equal to 0. So I didn't do anything. I split this middle term into its two parts. Here what I do is I take x as common, I get x minus a. And then I take minus b as common, I get x minus a. So then I'll write that either x minus a is equal to x minus a into x minus b is equal to 0. And again, based on the zero product rule, I can say that either x minus a is equal to 0 or x minus b is equal to 0. So x will be equal to a or x will be equal to b. So bachos, this is how we use the method of factorization to solve or to find the solutions, roots of any given quadratic equation. So students, we have come to the end of this conceptual and learning lesson in which we have learned the concepts of how and what a quadratic equation is, how it is formed, what its roots are or solutions are, what are the natures of these roots based on the discriminant, and the two different methods to find these roots or solutions. The next video, we will be bringing a lot of questions that have popped up in earlier ICSE exams to help you understand better how to approach given problems. And that video will be coming out very soon. To be informed about that, please like our video, subscribe to the channel and turn the bell notifications on so that you can get notified when that new video comes out. Apart from that, please go out and check out our channel for once, as Midha Guru has some faculties of utmost quality who bring up videos that will help you in your challenge towards the board exams. So till then, I'll see you soon and keep studying well. Namaste.